Welcome to this channel. Okay, you're welcome. Good evening, good afternoon, wherever you find yourself across the globe. We are looking at these very important topics. We are still on non-homogeneous differential equation. We've been talking about using undetermined coefficients. Okay, but now we want to use another method, which is called the variations of parameters for solving non-homogeneous second order differential equation. Each of those formulas, each of those methods have their own importance. The undetermined coefficient cannot solve all functions. It can only go for polynomial functions, the exponential, which I mean the e functions, the cosine, and the sin function. These are the areas where the undetermined coefficient is useful for solving second order differential equation. But this method goes for all functions. You can apply it for all functions. What is the formula? The thing you have to note is that when you have non-homogeneous differential equation, you need to get the particular solution. And the particular solution is b1 times y1 plus what? b2 times y2. This is a particular solution for the non-homogeneous differential equation, where your v1 as a function of x or whatever function you have in your question is equal to integral of f of x times y2 over a times Roskian of the function. I'm going to explain the meaning of this w, which I call the Roskian. W is called the Roskian. Okay, I'm going to explain that for you. And then you put your dx to that integral sign. That's your v1. Your v2, your v2 is integral of f of x, okay, times y1 over a times the Roskian of your solution of your y1 and y2. And then don't forget your dx. Okay, the step have not changed. When you have non-homogeneous, the homogeneous part of the equation, okay, you get the homogeneous part of the equation, and then once you write, for example, now let's say you have second differential. You have second differential plus 2 times first differential plus 4y, for example, now equal to 2 times exponential t, for example. The homogeneous part will be equal to what? Will be equal to this one, okay, plus 4y. And that will be equal to 0. That is the homogeneous equation of that differential equation. Then you now get the auxiliary solution of this homogeneous differential equation. The auxiliary equation for the above a r squared plus b r plus c equal to 0. So then you now correspond these standard equations with your differential equation, which will be equal to what? Which will be equal to the attachment to your second differential is your a times r. So you have r squared plus what? Your b attachment to your first differential in this place is 2, and that's your b. So that's 2 times what? Times r. The constant coefficient, the attachment to your y is 4, which will be your c. So plus what? Plus 4 equal to 0. So you now get the root of the auxiliary equation, the quadratic equation. It's going to give you two distinct. You can have many cases. You can have two distinct real roots, R1, R2. You can have equal roots where the R1 and R2, okay, is equal to each other. And lastly, you can have what? When you solve it, you can have two distinct complex roots. Okay, so you get your R1, you get your R2. Okay, so once you get that, then you can use that to get the Russkian. I'm going to explain that Russkian. You can use that solution of the auxiliary equation to get your Russkian. It's just a determinant. Let me explain that. Russkian is the functions of x. Hopefully, is a determinant of your of your of this auxiliary equation. Okay, let's say you have, for example, now you have your y1. You have, for example, you have r1 is let's say it's 2 here, for example, it's 3 here, for example. Okay, then you're going to have your y1 will be equal to e to power 2x. Your y2 will be equal to what? E to power 3x. So then you now come to your Russkian. Russkian, this is a y1, y2. Okay, then the next one will be what? The derivative of y1, which is 2 times e to power 2x. Derivative of this one will be what? 3 times e to power 3x. You solve the determinant and you get the Russkian, a W. Begin to like, share, and subscribe. Invite your friends to come in. Call your friends. Invite your friends. This is what we have. This is the non-homogeneous. This is non-homogeneous. Solve this equation. Second differential plus the first differential equal to tan x. Okay. In this case now, my f of x is what? Is tan x. Okay. And then the left hand side, the differential equation. Okay. If you equate to 0, that's your homogeneous equation. Okay. So step 1 to this question, since this is a non-homogeneous and it follow this format. Okay, and before we go, it follow this format. So the particular solution will be for you to solve this equation, and that will generate your what? Particular solution. That will generate your particular solution. Okay, and to get your y1 and y2, you must have gotten your the root of the auxiliary equation. Okay, you must have solved the homogeneous part of the equation. So step one, get the homogeneous equation. The homogeneous equation will be second differential plus y equal to what? Equal to 0. That's the homogeneous equation. Okay, the differential equation, the left hand side must be equal to 0, and the equation become what? Become non-homogeneous. Then step 2, get the auxiliary equation, which you are going to correspond with this differential equation. You're going to correspond this standard auxiliary equation with this form. The attachment to your second differential is 1 in this case. So 1 times r squared, you have that. Okay. We don't have I know I told you the r is the first differential, the r squared is the second differential. We don't have first differential in this place. So this place becomes 0. We don't have this one. We only have the constant coefficients. The attachment to your y is 1, which is your c. We don't have first differential in this case. R1 is your first differential. Second differential is your r squared. So that is the auxiliary equation. Then solve that, and that will be equal to r squared equal to minus 1. Okay, can you make r the subject of formula by taking the square root of both sides? And that will be plus or minus square root of minus 1. And that's giving you plus or minus I, which is imaginary number, plus or minus I. So that's what we have in that case. Then the next thing to do now is for us to get the solution of this R. Okay, this implies actually this one can be written as 0 plus or minus I. Don't have the real part, because when you have a complex number, this is a complex number. Okay, but we don't have the real part. The real part in this case is a real part, which is 0. That's the real part. The imaginary part is the I. Okay, but the attachment to that I is what we call beta. That's what we call the beta. The attachment to that I of that complex number is called beta. So then when we have this case, when you have a complex number, then your solution, your y1 will be equal to what? E times alpha x cos x. Then make a substitution. Your alpha is what we call the real part. Your alpha is 0. So e to power 0 is 1. So we only have what? Cos x. So this is a cos x. That's your y1. Okay? Then your y2. Y2 is also the same thing as e alpha x sine x. I didn't even explain this one. This is a beta. The general solution is cos beta x. Okay? Cos beta x. And my beta is what? Is 1. So it's going to give me cos what? Cos x. For this one also, you're going to have this, and my beta is 1. So put it there. And alpha is what? 0. So we have cos. We have sine x. Beta is 1 for y2. Beta is 1 for y2. So in that case now, we've gotten y1, we've gotten y2. We need to get the y1 and y2, which is gotten from the what? From the auxiliary solution to the auxiliary equation. Okay, so with that now, you can now get your Roskian. Your Roskian, okay, your Roskian is your Roskian. Don't forget, your f of x is a function of x. Okay, so the Roskian would be just a function. So everything we are doing is a function of x. Roskian of y1 comma y2. Okay, and that will be equal to determinants. That is determinants. This is y1. This is y2. This place will be derivative of y1. This place will be derivative of y2. Okay, so that's what we have there. I'll just substitute my y1 here, my y2 here, and I will get the differential of y1 and y2. Invite your friends to join us. Okay, and that will encourage us to continue. Okay, invite your friends to join us. Okay, so that's what we have. We just have to replace the y1. My y1 is what? My y1 is cos x, which we got here. My y2 is what? Sin x. My y2 is sin x. Then get the differential of that. The derivative of cos x is what? Is minus sin x. Okay. The derivative of cos x is minus sin x. The derivative of sin x is what? Is cos x. So this place will be cos x. And Roskian is the determinant. Okay. Determinant of this. Then we can get the value. We can get the value for that, which will be equal to this one times this one. So Roskian is equal to cos square x, then minus this one times this one, which is what? Which is minus sine square x. Okay, this is minus sine square x. So minus become plus. So you have cos square x plus what? Sine square x, and that's what? That's 1 in that case. So Roskian for this particular differential equation is 1. So, and we've explained that your A is what? Your A is also 1 because the attachment to our differential equation to second differential in this question, attachment to second differential is what? Is 1. So A is 1, A is 1, A is 1, A is 1. So the next thing to do now is for us to be working toward the particular solution, which is a V1 times a Y1 plus a V2 times a Y2. Okay, I've gotten V1, I've gotten V2. So what I need to do now is to get the V1. Okay, and my V1 has this formula. My V1 has this formula, which is integral of minus f of x times y2 all over what? My a is 1, a times the rho square of y1 comma y2, rho square of y1 comma y2, don't forget your dx. So that's what we have there. So which will be equal to my f of x is the right hand side of your differential equation, which is a tan x. That's a tan x. So minus a tan x. My y2 is what? This is my y2 sin x times sin x all over a is 1 from the formula. For your differential, for your question, a is 1. Rho square is also 1. So 1 times 1. And don't forget your dx. For writing the formula, there's a mark for you from the examiner, okay? And then for substituting correctly, there's also mark for you. So that's what we have there. My V1, we have this integral of minus my tan x is sin x over cos x times sin x dx over 1. Okay, so if you do this, it's going to give you the numerator, multiply them together, that minus sin squared x over what? Over cos x. Okay, so that's what we have there. We can use a substitution method to solve this question. You can use a substitution method. I mean, change your variable. You can use change your variable to solve this. Okay, and we can at the same time say use this one cos square x plus sin square x equal to 1. So sin square x is equal to what? 1 minus what? Cos square x. So we can use that if we like. We can use that for that question. Okay, we can use that for that question. Okay, so that's what we're going to do. So this will now become v1 is equal to integral of minus my sin square x is 1 minus cos square x dx over cos x. And the meaning of this, let's take this minus outside. So minus, it means 1 over cos x, which is a sec x. And then minus, don't forget that will be dx, minus cos x, cos square x over x. That's what? That's a 1 over cos. Okay, dx also. So just to the algebra of that, 1 over this, okay, and this 1 over this, okay. Okay, this 1 over this, that will give you for up there, that will be since, okay, the minus is already outside, okay, I can open and close the brackets, and this one cos square x over cos x, that will give you cos x. So you can remove these at the x from here. Then you have minus cos x, close the brackets, dx. So that's what we are going to get in that case. That's a 1 over cos x, okay, is a sec, okay, and then cos square x over cos will give you this, okay. So that's what we have there. That's what we have there. So that's what we have in that case. And if you integrate integral of sec x, it's going to give you, don't forget the minus outside, it's going to give you v1 will be equal to the minus outside. Let's do our work. That will be natural logarithm of sec x plus tan x. It's a direct table for sec x. That's the integral of sec x. Okay. Then minus integral of cos x. That's sin x. Okay. So that's the v1 in this case. So when you're getting your v1, v2, don't put we don't put plus c. For v2 has this formula, which is f of x times y1 over the a times rho square of y1 comma y2 and then dx. Okay, what now I want to tell you about the formula of v1 v2. Look at it now. This is your v1, which is minus f of x y2 dx over a times rho square of the function y1 y2. So when you're doing y1, okay, when you're doing v1, okay, it will be y2. Okay, you're going to use one of the roots, that will be y2. Okay, and for v1, this is the only place we have minus. For v2, there's no minus there. v2 will go with y1. Okay, another functions is constant. Rho square a rho square f of x. But for v1, we have minus. For v2, there is no minus. Okay, so when you're doing v1, have at the back of your mind to go with y2. But actually, some examiner will make provisions for all these formula at the back of your questions. Okay, so let's get the v2, which will be equal to my f of x is what? Is tan x. F of x is tan x times my y1. My y1, check that. My y1 is cos x over what? Over 1. A is 1. Rho square is also 1 dx. And that will be equal to tan x is what? Sine over what? Cos x times cos x dx. So this one and this one we cancel. You just have integral of sine x, which is a minus cos x. That's your v2. So finally, we now write our v. We write the general solution, particular solution. Okay, which is what? y1. Okay, that's the particular solution. Then make your substitution. Your v1, we have the value times y1. Okay, so that means times cos x. So it's going to be minus cos x. Share the links of this video across your different platforms. Share the links across your different platforms. Invite your classmates. If you are coming here for the first time, please subscribe to the channel. Subscribe now. Subscribe to the channel. If you are coming here for the first time, please subscribe to the channel. Like, share, and subscribe. Like, share, and subscribe. Like, share, and subscribe. Like, share, and subscribe. Invite someone. Call your friends to join us. Call your friends, your classmates. Call everyone to join us. What homogeneous parts. So that's a second differential plus y equal to what? 0. That's the first thing you do. Then second thing to do is to get the auxiliary equation. Get the auxiliary equation, which is equal to what? You write the standard equation for auxiliary equation. Okay, equal to 0, and then you now correspond together with the given differential equation. The attachment to your y, the attachment to your second differential is 1, which is your a. Okay, so a times r squared. That's this plus attachment to your here. No, I said the r is the first differential, so there is no first differential here. So that makes this one to be 0 here. So attachment to your y in this place is what we call the c. So plus 1 equal to 0. So if you solve this, we are going to get plus or minus I. If you solve that, you're going to get plus or minus I. Okay, and that will give you the solution of the auxiliary equation, which is a y1 equal to. It has this form: alpha x cos beta x. The beta is the attachment to your complex to I, which is 1. The coefficient of I is 1. Okay, and this equation can be written as what? 0 plus. 0 plus or minus I. So this is the alpha, this is the alpha, and the coefficient of I is your beta in this case. Is your beta in that case. So this will then we make your solution to this. Y1 will be equal to what? Cos x, because alpha is 0 and e to power 0 is 1, and then beta is 1. Then you can get the second solution, which is this form, sine beta x, and that's equal to what? That's equal to sine x. Then after that, you can go and get the Roskian of y1 comma y2, okay, which is a determinant. Roskian has a determinant, which is your y1 cos x, y2 sin x. And the next line is the derivative of the first row, which will be minus x. If you differentiate cos x, you have this. If you differentiate sin x, you have this. And solve this. These are determinants. So this will come here. This one times this one. That's a cos square x. Minus this one times this one. Minus sin x. So, and this one will be equal to 1. So that's the Roskian. That's the Roskian of that. Okay. So Roskian is 1, and your A is also 1. A is the coefficient of your second differential. Okay. So once you've gotten the Roskian, you've gotten your y1, you've gotten your y2, then tell us the particular solution has this formula. Okay, before we do that, I didn't even write the solution of the left-hand side, the homogeneous part. The solution of the homogeneous part is C1 y1 plus C2 y2, which is equal to what? Make your substitution. C1 cos x plus C2 sin x. So that's that for the homogeneous solution or complementary solution. Okay, then we can now get the particular solution, y of p, which has this formula. It has this formula, v1 y1 plus v2 y2, and then you v1 has a formula. V1 has a formula. V1 has this formula. There's a formula for the V1. That's the formula for V1. That's the formula for V1. V2 also has this formula. So that's that for that case, V1, V2. Okay, so that's that. So once you have the formula, for writing the formula, there's a mark for you. For writing this formula, there's a mark for you. There's a mark for that. Okay, so then we can quickly go to y1 is what? Y1 is cos x over 1 times 1. Roskian is 1. A is also 1 dx. Okay, and tan x is what? Is sine over cos times what? Cos x dx over 1. So this one and this one cancel. So we have integral of sine x is what? Minus cos x. Okay, then finally, just come back here, get your yp, particular solution, which has this formula. It has this formula. And then begin to make your substitution. Your v1 is here, times what? Times y1. So we now have minus is here. So y1 is cos x. So that minus cos x. Okay, open the brackets. You have this. Okay, minus sin x, close the brackets. Then for v2 is minus cos x. V2 is minus cos x times times the y2, which is sin x. Okay, so the next thing, final thing to do is to get the general solution, which will be homogeneous parts, the complementary solution plus the particular solution. Just substitute that, and that gives you the answer to that. So that starts on that. That starts on that. Okay. Begin to say I as you are coming in. Begin to say I as you are coming in. Say I as you are coming in. That will take us to another question. Find the general solution of the following differential equation, which is a second differential plus 4y equal to what? Z squared 40. So that's what we have in this case. Okay. This is variations of parameters for second order for non-homogeneous second order differential equation. So that's what we are looking into. We've already laid the foundation. Okay, we're looking at the applications of those foundation we have laid. Okay, so this differential equation is of this form. Um, so this form. Okay, where the f of x, is sec square 40. So that's the f of x. Your differential equation, we are told to find the general solution. And the general solution will be combinations of the homogeneous part, the solution of the homogeneous part, plus the particular solution for the non-homogeneous parts. Okay, and we are using variations of parameters. Okay, this case, there is no room. If you want to use undetermined coefficients, it will be very cumbersome because there is no room for sec square of a function, sec square theta. We don't have the room for that. We only have the room for cosine and sin function. Okay, so the best approach is variations of parameter. That's the best way to solve it. And actually, we are told to use variations of parameter. In this question, they didn't say that. Okay, but all the time coefficient cannot undo sec square of the function. It can't undo that. And if you undo that, it's going to waste your time. Okay, and it's going to be too cumbersome. Okay, the faster approach is to use your variations of parameters. So this is general solution. Okay, so where the yp for the variations of parameter is this formula. This is your yp. This is the formula for yp. V1 y1 plus v2 y2. So that's the general solution. That's the general solution. So what is the v1? Where your v1 has this formula. Your v1 has this formula minus f of x times the y2 dx over a times the Roskian of your auxiliary solution y1 comma y2. Your a in this question, the attachment to your second differential is a. So a is 1. A is 1 in this case. A is 1 in this case. And f of x in this question is sec square 40. That's your f of x. Okay. So before we can get the Roskian, we must have gotten this one. Before we can get w, you must have gotten the solution of the homogeneous parts. Okay. So let's get the homogeneous equation, differential plus 4y equal to 0. So that's the homogeneous equation. And there is a correction. This f of x is not f of x, is f of t. is a function of t. Auxiliary equation, get the auxiliary equation, get your auxiliary equation, and then your auxiliary equation, our auxiliary equation is going to be get the auxiliary equation, got the auxiliary equation, okay, get the auxiliary equation, and that will be equal to, you're going to correspond that with a standard equation, you correspond that with standard equation, for auxiliary equation, which is this one, okay, which means the attachment to your first differential is a, so that's r squared, a times this one. Attachment to your first differential is b, but we don't have first differential in this differential equation, so this one cancel, okay. The attachment to your y is the c, so plus what? Plus 4, got to 0. So make r the subject, r squared is equal to what? Move this one to the other side, that's minus 4. So r is equal to what? Plus or minus 2i, plus or minus 2i, which is equal to what? 0 plus plus or minus 2i, 0 plus plus 0 plus or minus 2i, okay. And this is a complex number, so this is a real part, which you call the alpha. The attachment to I is the beta, okay. The attachment to I is a beta, okay. So with that now, we can get the y1, which we got to what? I don't want to waste the time because your alpha is 0, so that will be cos beta beta x, but in this case, it's going to be cos. No, actually, this is the formula. This will be alpha when you have a complex number. This is your formula. Y1 is x. Okay, alpha is 0 in this case. Beta beta is 2 in this case. And don't forget, I said it's a function of t, so that will be beta t. So it's going to be what? It's going to be cos. Cos what? Cos 2t. Cos 2t. Then you can get the y2 also, which will also be the same thing also. Sine bt, and you can substitute the real part. So it's going to be what? Sine 2, your beta is 2t. So w is equal to y1, that's cos 2t, y2 is sine 2t. Differentiate this one, that minus sine 2t. Differentiate this one, that's a minus, that's a cos 2t. So this is determinant. What can is determinants? Okay, so that will be equal to this one times this one, that's a cos square 2t, and then plus this one, that will minus this one. So minus minus, that's plus sine square 2t. So we solve that, that's 1. It's an identity. When you have cos square 2t plus sine square 2t is 1. Okay, so once you do that, then you can get your, we've gotten the Roskian, and then a is also 1. A is a attachment to your second differential, a is 1. Then we can get the v1. You can get the v1, which is what? Which is equal to minus f of x. Okay, minus f of x. My f of x is what? Is sec square 40. Okay, times y2. My y2 is what? My y2 is sine 2t. Sine 2t all over 1 times 1. Okay, don't forget the t. It's a function of t. So we can take this minus outside. Take the minus outside. So sec is 1 over cos squared, the function, cos square 40, cos square 40 Okay, and then times what? Times sine 2t dt. Okay, is it 40? Let's check the question. Let's check the question. Sorry, that's a mistake here. This one is 2t. F of t is 2t. It's 2, not 4. So this will be 2. This will be 2. This is 2, not 4. Even on the front cover of this video is 2. I want you to finish it up. V1 is equal to finish it up. We'll continue from there tomorrow. Hopefully tomorrow we'll continue from this